Standard 10th Mathematics Part 2 Chapter based on Trigonometry in understanding the concept of trigonometric identities. In video number 6. Now children, in the earlier session, we got the first trigonometrical identity. What was the first trigonometrical identity? It was sine square theta plus cos square theta is equal to 1. This was the first trigonometrical identity. How did we get this first trigonometrical identity? Let's recall, what did we apply? We applied Pythagoras theorem for which triangle? For the right angle triangle ABC. And then we divided the whole Pythagoras equation by hypotenuse square. And we got sine square theta plus cos square theta is equal to 1. How do we get the other identities? Before we plunge into understanding the other identities, let's first revise the basic trigonometrical functions, their ratios. What did we find out? We knew that for the basic function sine theta, its multiplicative inverse this was the basic function. Sine theta, its multiplicative inverse is what, children? The inverse or reciprocal of sine theta was 1 upon sine theta. But instead of saying 1 upon sine theta, which is the new word of reference that we use, it is cosec theta. So what was cosec theta? It was the reciprocal or multiplicative inverse of sine theta. Which was the other one? It was cos theta. The inverse, we always write it as 1 upon cos theta. But instead of saying 1 upon cos theta, which is the new word that was written as 1 upon cos theta? It was sec theta. That means cos and sec theta are multiplicative inverses of each other. The third basic function was tan theta. So the inverse or reciprocal is 1 upon tan theta. And 1 upon tan theta was written as cot theta. That means the inverse of tan is cot, or multiplicative inverse of cot is tan. Both the ways you can write down the reference. What else did we study, children? We studied that sine theta upon cos theta was equal to tan theta. In other words, if I take the reciprocal, cos theta upon sine theta, we prove that it is equal to, what is the inverse? When we take inverse of sine upon cos, it becomes cos upon sine. That is equal to cot of theta. This is all that we studied in the earlier sessions. Now, to get the trigonometrical identity, the second trigonometrical identity, what do? We use the first one. What is the first one? Let's jot it down. Sine square theta plus cos square theta is equal to 1. This is the first trigonometrical identity. Let's divide the whole equation once by sine square theta and get the answer. For the third trigonometrical identity, let's divide the whole equation by cos square theta. So let's begin, children, dividing the whole equation by sine square theta. So that means each term in this given equation is divided by sine square theta. So sine square theta upon sine square theta plus cos square theta upon sine square theta is equal to 1 upon sine square theta. The reason that we write for the statement is dividing equation 1 by sine square theta. What do we get over here, children? Sine square theta and sine square theta gets reduced. So what are we left with? 1 upon 1, that is 1 plus. Now children, cos square theta upon sine square theta, definitely we can write a square upon b square can be written as a upon b the whole square. Let's apply the same logic over here. Cos theta upon sine theta the whole square, which is equal to, over here children, 1 upon sine square theta can also be written as 1 upon sine theta the whole square. The whole square. Why? Because 1 square is 1 upon sine theta the whole square is sine square theta. So you get back the original term. Now let's substitute by comparing it with whatever we have written for the basic functions and their inverses. So 1 plus cos theta upon sine theta. Do we have the term over here where it can be substituted by some other value? Let's check. Cos theta upon sine theta. Definitely children, cos theta upon sine theta is cot of theta. So over here inside the bracket we will have cot of theta the whole square. Let's not forget it, which is equal to 1 upon sine theta. What is 1 upon sine theta? It is equal to cosec theta. So 1 upon sine theta can be written as cosec theta. Let's again not forget the whole square. So children, here we get the other identity which says that 1 plus cot theta the whole square can be written as cot square theta, which is equal to cosec theta the whole square can be written as cosec square of theta. This is the second trigonometric function. 1 plus cot square theta is equal to cosec square theta. If you want to apply it for the other acute angle in the right angle triangle, then instead of theta what will you substitute? 90 minus theta, that is 1 plus cot square of 90 minus theta, which is equal to cosec square of, instead of theta our angle is the other acute angle, that is 90 minus theta. So the first identity was sine square theta plus cos square theta is equal to 1. The second identity that you received, you concluded was 1 plus cot square theta is equal to cosec square theta. Or in other words, if you want to write it with the same frame, then you can transfer cot square theta on the other side. What is left on the left hand side is 1, which is equal to cosec square theta plus cot square theta goes on the other side, that is minus cot square theta. So in other words, cosec square theta minus cot square theta is equal to 1. This is the second identity in trigonometry. So let's write it down. The second identity, and how did we get that identity? By dividing the first identity sine square theta plus cos square theta is equal to 1 throughout by sine square theta. So that was cosec square theta minus cot square theta is equal to 1. This is the second identity. Now children, to get the third one, logically what will we do? Again, we are going to take support of the first trigonometric identity. Which was the first trigonometric identity? It was sine square theta plus cos square theta is equal to 1. Already we have finished dividing by sin square theta to get the second identity. Now we'll divide the whole equation by which term? Definitely cos square theta. So let's first write down sin square theta plus cos square theta is equal to 1. Will I be dividing the whole equation again by sin square theta? Definitely not, because by dividing by sin square theta everywhere, I've got the second identity already, that is cosec square theta minus cot square theta is equal to 1. To get the third trigonometrical identity, what do we divide it? We divide it by the other term. So dividing the whole equation by cos square theta. So each term has to be divided, children, upon the same cos square theta. Whatever you do on the left hand side should also be done on the right hand side. 1 upon cos square theta. Let's see now what happens. Sin square theta upon cos square theta. A square upon b square. Again can be written as a upon b, the whole square. So over here it will be sin theta upon cos theta, the whole square, plus cos square theta upon cos square theta definitely gets reduced. So you are left with only 1, which is equal to 1 upon cos theta, the whole square. Because 1 square is 1, cos theta the whole square is cos square theta. So definitely you are getting the same term back which is in the preceding equation. Now let's check, children. Sin theta upon cos theta. Can we substitute some value for sin theta upon cos theta? Only one term? Definitely. Sin theta upon cos theta is equal to tan theta. So here sin upon cos will give you tan of the same angle theta, the whole square, plus 1, which is equal to 1 upon cos theta. What is the inverse of cos? It is equal to sec. So instead of 1 upon cos theta, we can write the inverse, multiplicative inverse of cos, that is sec. So it will be sec theta. Let's not forget the square. So finally what did we get, children? Tan theta, the whole square can be written as tan square theta plus 1, which is equal to sec square theta. This is the third identity. How did we get the third identity? By dividing the whole first trigonometrical identity by cos square theta. So what can we conclude, children? Tan square theta plus 1 is equal to sec square theta, or in other words, take tan square theta on the other side. So what are we left with? 1 is equal to sec square theta plus tan square theta goes on the right hand side. So it changes its operation. So sec square theta minus tan square theta is equal to 1, or in other words, sec square theta minus tan square theta is equal to 1. So this is the third trigonometric identity. For all the three you see that you get the answer 1. That is why they are called as trigonometric identities. This was in reference to one acute angle. Can we apply it for the other acute angle? Definitely. Instead of theta, what will we substitute? The other acute angle measurement. So it will be sec square of 90 minus theta minus tan square of 90 minus theta, which is equal to 1. Or in other words, sec square c minus tan square c is equal to 1. Or sec square theta minus tan square theta is equal to 1. If your reference is the other acute angle, then sec square a minus tan square a is equal to 1. Or if the measurement is given, sec square 90 minus theta minus tan square 90 minus theta is equal to 1. So this was the third trigonometric identity. So it was sec square theta minus tan square theta is equal to 1. This is the third trigonometric identity. So it was very easy, children. How did we get the first trigonometric identity? We applied Pythagoras theorem, ab square plus bc square is equal to AC square. Dividing the whole Pythagoras equation by AC square, we get the first trigonometric identity. To get the other two, what do? We take support of the first one. For one method, we divide the whole equation by sine square theta, where we get the second trigonometric identity, which says cosec square theta minus cot square theta is equal to 1. To get the third, we divide the whole first trigonometric identity by cos square theta, where we get sec square theta minus tan square theta is equal to 1. So these are the three trigonometric identities.